I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life,
the universe.
Hello, this week we're stuffing our suitcases with your holiday questions. Coming up, why do we get heat waves? Should we really wee on a jellyfish sting? And why does the sun bring out freckles? I'm Chris Smith, and this is The Naked Scientist.
The Naked Scientist podcast is powered by ukfast.co.uk.
Let me introduce the panel of people who are going to help me to answer your science questions this week. With us is Jim Bacon. He's from WeatherQuest. They're a weather forecasting and weather analysis company. And listeners to The Naked Scientists in the long term will recognise Jim because about, we think, 12 years ago, isn't it, Jim? You lent us your particular office at the University of East Anglia to make a special edition of the programme during the British Science Association Festival when we came to Norwich.
That's right. Long while ago now, it seems. The weather's a lot better since then, isn't it? So that's gone very well.
Indeed. Well, anyway, welcome back. 12 years later, you're going to answer questions about the weather and meteorology. Have you got a fun weather fact you can impart to us?
Well, it's perhaps a little bit surprising to some folk that in the middle of such hot weather, when you do get a heat wave, that most of the rain that comes along to end it actually starts off as snow. In the upper atmosphere, the rain-making process depends upon the mixture of supercooled water droplets and ice crystals, and that is fundamental to most of the rain we get in mid-latitudes. So when it's 30 degrees and you get your first heavy thundery downpour, you can say, that was probably snow 10 minutes ago.
Or a hurricane, in Michael Fish's case.
Well, we're not going there.
Sitting next to Jim is Jane Sterling, also a stalwart of the programme because you were one of the first ever guests to take part in The Naked Scientist when it was first formed. Jane, you're a dermatologist at Adam Brooks Hospital. Have you got a skin fun fact for us?
Well, Chris, that's taken me back a long time, isn't it?
About 18 years.
Let's move on. So we're going to talk quite a bit about the sun and the bad things it might do to us today, but I've got a good thing about the sun, and that's that the sun hitting our skin does help to make vitamin D. Very important for strong bones and various other things, but you can get enough vitamin D made in your skin just by hanging out the washing every day, 5 minutes in sunny weather if you're a fair-skinned person.
And is vitamin D deficiency a big problem in many countries?
Well, it's surprising, but when you test lots of people in the UK, a large proportion of people are vitamin D deficient, and that has an impact on strength of bones and perhaps getting fragile bones later in life. So it's well worth looking out for vitamin D. And if you're deficient in vitamin D, there's also some evidence that you're more likely to get troublesome skin cancers and various other cancers. So
paradoxically, by going out in the sun, you can protect yourself from skin cancer.
Just a little bit. It's when you have too much. That's
Thanks,
the problem.
Jane. Howard Griffiths is Professor of Plant Ecology at the University of Cambridge and sitting at the other side of the desk. Welcome, Howard. Now, I've always wanted to ask someone who's a plant scientist, are you good at gardening?
Well, believe it or not, yes, I am quite a keen vegetable gardener. I do a little dibble in the herbaceous arena as well occasionally.
You dabble in the herbaceous?
I certainly do, when nobody's looking.
No. Have you got a plant science fact for us?
Well, yes, I think it's consistent with a day of Formula One racing to tell you that some plants have turbochargers. And for those of you who've ever thought of the prospect of taking their children to a maze in August and losing them, no, I'm sure you don't want to lose them, but that's a crop that grows fantastically fast once it gets hot and warm enough. And so maize and its close relative sugarcane are plants which have a photosynthetic turbocharger.
What is that?
Well, what it does, it force feeds carbon dioxide into the enzyme that drives carbon gain by the plant.
And that makes it grow much better.
And that enhances their productivity.
And is it just those plants that have this, or do others
There's
have it
quite
too?
a few others that have it as well, but they're the major sort of crop plants that have it. And there are plans afoot and research being done to see if we could actually introduce that same pathway into rice, to make rice more productive, to feed the world for the future.
I'm glad you're on the case, Howard. Thank you. So, any plant sciences questions, they're going to be going Howard's way. Sitting next to Howard is Lawrence Kemp. He's a GP and he's also from the Cambridge University School of Clinical Medicine. So, do you get lots of people who come traipsing back from their holidays abroad and their sojourns in the sun, Lawrence, and they've been up to no good and done naughty or silly things and you end up sorting them out?
Yeah, that's a relatively common thing we see in general practice this time of year. Probably want to not go into too specific instances. Just to,
patient confidentiality aside.
All of that. We've got to have to take that very seriously, don't we? But no, this time of year we see people with holiday-related injuries, maybe holiday-related infections, some of the kind of weird and wonderful tropical medicine that I don't see a huge amount of in Cambridgeshire can come my way. So it's always an interesting time of year.
And the most frequently asked question as a GP that you get from patients sitting down in that chair next to your desk?
That's a difficult one, isn't it? I think probably the most frequent condition we see in general practice, in the UK anyway, is back pain. So a lot of people ask me what's caused their back pain and how long is it going to last and what can I do about it.
And these aren't just crash for cash victims who are after the insurance.
I don't think I've ever come across someone that I've been convinced is a crash for cash victim. But no, we hear a lot about that, don't we? But not something I've experienced much of.
Thank you, Lawrence. Jim, let's start with one for you, which has been sent in by Philip.
Why do we get heat waves? And what's this jet stream we hear so much about?
Really good question. And like all good questions, there are short answers and probably very long answers. I'll try and make this one a fairly short answer. The atmosphere consists of a lot of heating that goes on around the equator and not very much heating around the poles, and it's a very imbalanced system. And the jet stream is, in a sense, a response to the imbalance when you get warm air very close to cold air en masse. You could say, you'd think that it would just degrade gradually from the equator to the poles, gradually get cooler. But in actual fact, in the real world, what happens is you get zones where it gets to be a very intense demarcation between two different air masses, say one coming up from the south, from the tropics, and one coming down from the north, from the poles. And to make the atmospheric forces balance the motion, the jet stream is a strong wind that forms to do just that. So you get around the whole northern hemisphere. I don't know, it's probably easier to go into electronics here and picture an oscilloscope trace with a sine wave on it. And if you had that and joined it up all around the northern hemisphere, you'd have a complete set of undulating ridges and troughs going around.
Why does it wiggle like that?
Well, it wiggles because of the instability in the flow, and there are two or three types of wave motion. So one of them is what's called a Rossby wave, which is a very long wavelength caused by disturbance over big mountain ranges, and it's a planetary scale thing. And you might fit about 5 of these around the whole northern hemisphere. And then superimposed on that, you'll get a slight disturbance, a small perturbation, we call them, which is the sort of thing that represents lows that travel across the Atlantic and give us our weather. And those features can transport warm air northwards much quicker and bring cold air southwards. And they have the ability in this flow stream to amplify, and they grow into much bigger systems. So eventually what happens, our nice sine wave, given the right conditions and instabilities, can distort enough to become very high amplitude waves on the oscilloscope. And the general rule is if it's a very shallow thing, they ripple across really quickly. So our weather's very changeable, totally unlike now. It changes. One day you've got a low coming in with a lot of wind. The next day you've got a fine spell of weather, and then the next ripple comes through and brings another low. But what happens when it gets bigger is that the pattern slows down. And the pattern slows down and can at some stages come almost to a halt and tend to want to move westward. So instead of our systems coming from the west to the east, they can want to go from the east to the west. And that's what we in meteorology call a blocked weather pattern. And it's those blocked weather patterns that are associated with particularly long-lasting spells of weather where you get the same type of weather for several weeks instead of changing every other day. And there's one special case of blocked pattern where this nice sine wave forms a very contorted pattern which looks like the Greek letter omega. And that virtually can stay locked to a longitude on the globe for weeks and weeks at a time. Some of you will doubtless in this country, and I'm sure there are equivalencies all around the world, where the pattern has become locked. And in our country, we had in the UK, we had a big drought in 1976, and that was one of these blocking patterns. We had a barbecue summer, famously, when we didn't actually have a summer, when we got stuck in the loop of this blocked pattern. Yeah.
And we just got, continuously bad weather?
Continuously bad weather.
Right.
Because the whole pattern stops moving across the Atlantic and it's stationary. So the interesting thing is you've got to be stationary underneath the block, the ridge of the omega. And if you're not, you're in the bad weather. And that was the barbecue summer. So the idea of it being a good summer was that the block would stop with us under the ridge. But in fact, it was only a few degrees of longitude out, 10, 20 degrees of longitude out. And that meant that we were under the bad weather. So we had a summer like that. This year, and in 76, we are under the top of the omega.
Well, while we're having all this brilliant weather, you might have the opportunity to do a bit of sensible sunbathing. And Jane, we've got this question from Harriet for you.
Why does sunburnt skin flake off rather than turning me into a beautiful bronze goddess?
Well, I think that's a great question, but we're all thinking about the beautiful bronze goddess rather than the flaky person, aren't we? Let me take the end of the question first, because I think there is something aesthetically very pleasing about even-toned skin and perhaps not too pasty. In this country where we don't always get a lot of sun, as we've just been hearing, a little bit of a hint of colour to the skin is regarded as being attractive. But I think the quickest way to being a beautiful bronze goddess is probably to have a spray tan. So I'll just put that one in first. But the sunburn business, very important. So sunburned skin is bad news. That means that you've had enough damage from ultraviolet light to cause damage to your DNA. And sunburn is the process that the skin is going through to try and repair the damage that's actually happened from the ultraviolet light.
So there's inflammation in the skin after you've been hit by that deluge of
yes.
UV from the sun.
So as the skin tries to recover from that damage, it's inflamed, and then as inflammation settles, you get the peeling, just like you do if you have a scratch or some other sort of inflammatory process in the skin. Eczema, psoriasis, that are common skin disorders, they both have inflammation, they both have flaking.
So does that mean to get a suntan, you have to damage your skin en route to becoming a bronze goddess or god?
Yes. You do a little bit of damage every time you go out into the sun. But if you are definitely pink and burnt, then you've done a lot more damage and there's a lot more recovery to happen.
So is the best approach to do a sort of graded exposure then? So you have a little bit of sun exposure and go a little bit brown, and then a bit more exposure and go a little bit more brown if you're seeking to adapt your skin to sun exposure. So you don't ever burn, but you just accrue a sun tan.
That would be the perfect process. So on holiday, it's always best to never get burnt. And you have to know your own skin and the sun and the intensity of the sun quite well to know exactly what that means. But if you can avoid getting any pinkness to your skin when you go out in the sun, if you go to the Med, just have enough sun exposure to get a little bit brown, then you'll be doing the best you can for your skin.
So there you go, Harriet. Sensible, gentle sun exposure to go a little bit brown at a time is the answer. Now, Howard, Claire says on Facebook, this one for you.
Why is my hay fever so bad this year?
Lots of people can identify with this. What do you think?
I think I'd better just say, first of all, I'm speaking from the plant perspective, and we maybe better ask Lawrence to give us the more medically based solution. But I think it's probably due to the fact that in the UK, we had a rather late spring this year, and then it suddenly went very dry. And so we've had a very short growing season. And there are some plants which are wind pollinated, which means that they produce huge amounts of pollen, which can then be dispersed on the wind to find the female parts of adjacent flowers. Plants like many trees and many grasses, of course. And so I think that the problem has been that there's just been not much rain to wash that pollen out. So there's just been a huge amount around.
And is that your experience, Lawrence? Are you seeing lots of patients complaining of hay fever symptoms?
Yeah, I mean, much more than normal. I think I've been a GP in South Cambridgeshire for 7 years, and this is definitely the worst year. So normally, probably this time of year, maybe 4 or 5 consultations a week with people with hay fever problems. I think we're kind of more like 20, 25 at the minute. So it's certainly a bad year for it.
And if you see a patient with those symptoms, what do you advise?
For the majority of people with hay fever, you've got to remember it's a really common condition. About 1 in 4 people suffer with hay fever. Most people, it's going to be fairly mild. They can get an antihistamine from the chemist, maybe a steroid nasal spray, some eye drops. It's only a small minority of people who are going to get more significant symptoms and going to need to come and see a doctor. And actually, if they see me, generally speaking, it's just similar types of products, but a little bit stronger prescription strength, more potent antihistamines. Usually we can get it fairly under control. The good thing is it's something that goes away after a few weeks, usually anyway.
One symptom I've had of mild hay fever, because a little bit of hay fever myself, is that I can get my ears feeling itchy on the inside. So you can't actually scratch them, but you can feel the inside of your ears as if you want to get your finger in and really scratch it. But that was a fairly weak seg into this question for you, Lawrence, from James.
What's going on in my ears when they pop after a flight?
So James has obviously been off on his holidays, and when you come down in the aeroplane, you do feel your ears doing funny things. So what's that all about?
So that's a pressure thing that's going on there. If you think of how the ear works, from the outside of the ear, there's a small little ear canal which takes you to the eardrum. And then the other side of the eardrum, you've got what we call the middle ear. Now, in order for the hearing to work properly, you need an equal pressure on either side of the ear. And that way the eardrum will vibrate when the sound waves hit it, and that'll be taken through to the inner ear where the hearing happens. So when you go up in a plane, for example, the plane is, although they're pressurised cabins, they're not fully pressurised to atmospheric pressure. So as you go upwards, the pressure within the cabin drops off a little bit. That causes your eardrum to gradually bulge outwards because the pressure within the middle ear is higher. Now, your body's way of resetting that pressure difference is to open up a little tube called the eustachian tube, which runs from the middle ear into the back of the nose. And we open up that tube by yawning, by swallowing. So what you notice in a flight is as you go up, your ears might begin to hurt a little bit. You swallow, you yawn, maybe you pinch your nose and blow, and that opens up these tubes, equalises the pressure, and that usually relieves the symptoms. Same thing when you come down again, your ears get used to that slightly lower pressure, and as you come down again, same thing happens, but in reverse. That time you're letting air in. Interesting thing is that children, or babies in particular, and kind of children toddler age, their tubes are relatively much smaller and open much less than an adult, which is why it tends to be the young kids on the flight that are crying when you go up and go down, rather than the grown-ups, or maybe they've just tolerated a bit better.
It's a similar phenomenon when one dives into a swimming pool and swims very deep, or goes scuba diving. If you go scuba diving on your holidays, then you may feel pressure in your ears and you blow down your nose, holding your nose, and you can equalise the pressure that way. It's the same phenomenon, isn't it?
It's the same thing, but obviously with water being so much denser than air, actually you can achieve much greater pressure changes just by, you go up in an aeroplane, although you're going to 36,000 feet, because it's pressurised, that pressure drop is kept fairly modest. If you go diving about 14 metres underwater, there's enough pressure there that you can, seriously damage your eardrums unless you know what you're doing.
Jane?
Yes, I was just going to ask, I know they often hand out a boiled sweet, don't they, just before you land on a plane?
Depends on your airline, I think.
Yeah, well, yes. Depends where you're sitting on the plane.
Airline, Jane.
I've never found that helps very much. I find the yawning is much easier to make your ears pop. I just wonder if the little bit of swallowing you do probably after a boiled sweet does anything, or is it just bad for your teeth?
I think swallowing helps. It opens it up again, but I don't think it's nearly as effective as holding your nose and having a good blow to open them up.
Bad for your teeth, great for your dentist's wallet. You're listening to The Naked Scientists with me, Chris Smith, and this week we have a panel of experts who are taking on your science questions. On the way, how do you treat a jellyfish sting? Why does the sun bring out freckles? And why does grass turn yellow when it hasn't been watered? Plus, don't forget, our quiz is on the way. But first, according to Cancer Research UK, there were almost 16,000 new cases of melanoma, that's a kind of skin cancer, in the UK alone in 2015. And it said that up to 86% of them could have been preventable because they're, as Jane was saying earlier, linked to sun exposure. So how does sun cream work, and how important is the use of sun cream in protecting us? Well, with us to explain is Andrew Farrer. He's from the Cambridge Science Centre and he's coming to do a demo for us. Andrew, tell us what you're going to do.
Hi, Chris. Thanks for having me. So what we're going to do is I've got a standard fluorescent highlighter pen, the kind that we've all used when we've had to revise or we're marking up important documents. What I'd like you to do with it is just write something on your arm, please.
OK, so I'll choose yellow because that's nice and bright, isn't
Yellow
it?
is a good colour.
I think I'm going to write naked. There we are. So I now have the giant words naked in fluorescent ink down my forearm of my right arm.
So what's really cool about fluorescent markers is fluorescence is actually a chemical thing where UV light is too high an energy wave from the sun for our eyes to detect. But if it hits a fluorescent chemical, what actually happens is that chemical bounces the UV light back, but it lowers the energy into something visible.
Oh, right. So it takes the energy out of the UV and then converts it into a colour of light that we can see.
Effectively, yes. It's the electrons in the atoms and the molecules are absorbing the energy of the UV wave, and they bounce it back, they reflect it back. This is how we see all colour. But the electrons don't give all of the energy back again in the terms of when it's fluorescence. So if we have these UV torches that we have here in the studio and shine them on your arm, what we should see is that the word naked suddenly becomes
I now have
very bright.
A very brightly glowing naked on my forearm.
Exactly, and this is the conversion of UV back to visible light and makes it glow. We use this in police vests, in the kind of vests you see on workmen using on the side of the road. So this makes that bright yellow green that they're wearing even brighter because the UV from the sun brightens it up again. But what we have here is a tub of factor 50 sun cream. What I'd like you to do now is just take a small dab of it on your fingers and just cover part of that word, of the word naked.
So you want me to smear a dab of
just to
sun
smear
cream
a dab of. Let's do it over half the word so we can see the comparison.
Right. So
exactly.
I'm just liberally putting this over half the word naked. I might have got a bit carried away, but okay. And I'm now covered in sun cream as well. I won't touch any more knobs in the studio. Yeah, right. Okay.
So the point of our sun cream is to block the UV from reaching our skin. So it's going to absorb all of that UV light before it hits your skin, and also now before it hits the ink of the highlighter.
Yep.
So if we shine the UV on it now, the part of the word that is still exposed that you didn't put sun cream on still glows, but underneath the cream there's no glow at all. We can still see the yellow colour faintly of the actual ink, the normal colour, but we don't get that fluorescence happening.
Yeah, I mean, the amount of UV light from this UV torch I'm shining on my arm that's reaching the dye to make it glow is massively reduced.
Absolutely.
Where the sun cream is.
Exactly.
So
And
how does sun cream do that?
Well, a factor 50 absorbs the UV light. Well, all sun cream absorbs the light. About 2% of the UV rays will get through a factor 50. But just like any light is absorbed by the molecular structure of whatever chemical, whatever substance it's bouncing off, and in some cases it's bounced back at us. In this case, the sun cream is just retaining all of that energy, converting it in a different way.
And Jane, when a sun cream says factor 50 or factor 30, in practical terms, what does that mean?
The number relates to the amount of time you should be able to spend in the sun so that you can judge how much damage the sun is likely to do to you. But the problem about the way you were putting the cream on, if I might say, is that you had a big thick smear.
Yep.
And nobody wanders around the street or lies on the beach or goes for a swim with that sort of thickness of sunscreen on. And the tests that were done, when they're done, they assume quite a thick layer of sunscreen, and most people put a tiny smear on.
Right.
And so they're not really getting the proper protection from their sunscreen use.
So you're saying you should be doing what I did on my arm? Because when I go on the beach or when I go sailing and things, I do put a really thick smear on my nose because I'm aware of the fact my nose has been burned in the past and also it's quite exposed.
Absolutely.
So that's what you should do.
So ears and nose and top of your head are really, they get a lot of sun. So in an ideal world, you would put a thick layer on. But of course, nobody's going to do that. So you do need to make sure you repeat application during the day.
Right.
It's estimated that if you are lying on a beach, let's say in your swimming trunks, and you're just going to stay there all day, you should certainly apply cream at least 3 times a day, and that you should use about 30 mils or 30 grams for each application. So most people, when they go on holiday, they probably take 1 bottle of sun protection cream with them, and that's way not enough. So the other thing is the 2 different types of sun protection in sunscreens, and the best ones to go for are ones that both reflect and also absorb. You were talking about the absorbing properties of sun creams, but the ones that reflect, which of course perhaps do look white when you put them on, they give you extra and better protection than just using the energy-absorbing ones.
Thank you very much. Jim, can you help us with this question that's coming from Tim on Facebook, who said, is there any truth in the saying, red sky at night, shepherd's delight?
I kind of have a soft spot for weather sayings because when I was younger I used to work on a farm and the guys there would have a great innate knowledge of what the weather did, and they would use these weather sayings as if they were kind of gospel, and most of the time they are. And what I like to do as a meteorologist is to look at some of them and think what would be the physics behind it. So the red sky in the morning, shepherd's warning and so on is to do with the fact that in general these were all developed at times before we understood meteorology. So it's going back to the Middle Ages and before, when people had to try and remember what a certain sky meant. And red sky in the morning means that the sun rising in the east is shining on clouds coming from the west, and most of our weather comes from the west, so it was a sign of bad weather. And red sky in the evening, was the reverse, and it meant that the sun setting in the west was shining on the clouds going away to the east, and therefore the bad weather was going away. So weather proverbs are not without value. They've been honed over the years. The trick is really to know when to get them out the toolbox and when to leave them in there, because they don't always work.
Thank you very much, Jim.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
You're listening to The Naked Scientists. My name's Chris Smith, and I'm joined by a panel of experts ready to take on your science questions. We have weather expert Jim Bacon, dermatologist Jane Sterling, plant expert Howard Griffiths, and for all things health, GP Lawrence Kemp. If you want to ask us a question for a show like this one, why not tweet it in to @NakedScientists? You can find us on Facebook, or you can head over to our forum. That's thenakedscientist.com/forum. Right, we'll get back to the questions you've been sending in shortly, but first it's time to get quizzical, because it's always good to test the mettle of our intelligent panellists. So we're going to have two teams. Team 1 is going to be Jim and Jane, and Team 2 is going to be Howard and Lawrence. Now, Team 1, Jim and Jane, you may confer. This is marine life or marine lie. Do you see what we did there? These are things that you might or might not find at the seaside. So can you tell us, which of these unfriendly sea creatures would you be most likely to encounter on the Ningaloo Reef in Western Australia? A fruminous bandersnatch or a tasselled woebegone? What do you think? Please confer.
I have no idea. I like the idea of the tassel. Some of these tropical fish, they have quite tassely tails, don't they?
Happy to go with that.
Okay, so you're going with the tasselled woebegone?
Yes.
Okay, it is... You got a ding-dong. It's a type of carpet shark. A bandersnatch is, in fact, a mythical creature which was made up by Lewis Carroll in the poem The Jabberwocky.
Yes, of course.
So, very well done. Right, Team 2, which is, of course, Lawrence and Howard. Which of these two would be most likely to pose in your photograph? A Wunderpus photogenicus or a Thaumoctopus fabulus? Which two would be more likely to appear in your photograph and pose for you?
I'm not sure. I'd probably go for the first one. That sounds a bit more...
it sounds a bit more scientific.
Sounds a bit more scientific. We think that's got a scientific feel about it.
You like the name? Yes, it is Wunderpus photogenicus. The clue's in the name. It's a spotty octopus living in the water around Bali. Gets its name because the pattern of spots on each octopus is unique. And here's the science bit. Much like fingerprints, it means that these octopodes can be monitored in the wild through people photographing them. Thaumoctopus fabulous is in fact made up. So it's level pegging at the moment, right? Everything's played for. Back to Team 1, who are Jane and Jim. Travel in style, the ultimate holiday accessory, is round 2. Does this cool holiday accessory actually exist? True or false? The USB air-conditioned shirt. Jim and Jane.
Don't see why it shouldn't.
There's a lot of talk about embedding electronics into clothing, so I'd probably assume that's something you plug the shirt in and you have a...
You can certainly attach a fan,
Yes,
even if you're low-tech, couldn't you?
I'm just not quite sure how the air conditioning would work, though. What little magic in there, having plugged it into
True or
your
false?
USB? Okay. What do you think?
I'd go for a go. Oh, yes.
Well done. Yeah.
It's true.
Lucky.
All you need is a laptop to charge up your shirt, which keeps you cool on your sweltering hikes or off in the airport where there's no air conditioning. Should your air-conditioned shirt power out, you can run it on batteries as well. Isn't that nice? Right, Team 2, here we go. This is back to Lawrence and Howard. What about a pair of money-finding, metal-detecting sandals? Real or something we made up earlier?
I can't imagine there's a market for metal-detecting sandals, is there?
Not really. There may be quite quaint willingness to wear them, I'm sure, if they were on the market. Maybe it's a marketing opportunity we should think about. What do you think?
Yeah, perhaps it is, but
but I'm not convinced that one could probably get one off some marketing electronic site, let's say.
So should we...
Howard is not convinced.
Should we say false?
Yeah.
Yeah,
You're going false?
Yes, go
Yeah.
false. Oh.
Please.
No, I'm afraid, actually, this is a real phenomenon. Actually, there's a battery pack which straps onto your ankle and then down to these flip-flops or thongs if you're Australian. This actually makes it look like you've been tagged by the police. Would you like to see a picture just here in the studio of what this wonderful invention looks like? I've printed out a picture. Look, you can see there. It's a pair of sandly things, and then you've got this wire coming out the back which goes up to this thing wrapped around your leg with a black box about the size of a TV remote control and some lights and LEDs. So it does look like you've been tagged because you're an ASBO or something. But you can, in fact, detect metals with your footwear. But it's good for beachcombers, apparently. They can pick up coins on the beach that obviously their sandals can detect. I bet they're worth their weight in gold, aren't they? But you make a fortune. Round 3, destination unknown. Which of these is a dud or a dream destination, Jim and Jane? Which one actually exists? Disaster Cafe in Spain, where they simulate a massive earthquake every night while you dine, or Hot Plate Iceland, where they cook the food on heat from a volcano?
Oh, I think the volcano must be
I
real,
like the
mustn't
sound
it?
of the Iceland one.
Yeah,
Yes.
we're going for Iceland.
Yes.
Oh.
No, I'm afraid, actually, Disaster Cafe in Spain is the correct one. Normally people are terrified of earthquakes, but at Disaster Cafe, which is at Lloret de Mar, people actually pay to experience a simulated 7.8 on the Richter scale quake while they attempt to enjoy their meal. You didn't get that one right. So you're still in with a chance. Howard and Lawrence, here we go. Which bar is a real one? The Underground Bar in London, where a bar on a train travels around a disused underground route. Or the Jumbo Stay in Stockholm. This hostel and bar is inside an old jumbo jet. It's open 24/7 rather than 747. Boom. It's outside the Stockholm Arlanda airport. What do you think?
What do you reckon, Howard?
Well, there was some talk of opening up the old Royal Mail line, wasn't there? And maybe there is a bar that zooms around that. In the London Underground.
I kind of think if that was open, I'd have known somebody who would have gone there and told me how great it was.
But don't you think?
It might be rubbish.
A bar and a jump.
We didn't say it was any good.
But then again, the bar outside Stockholm is going to be hugely expensive. But
Well,
anyway,
I'm gonna go for
I'd be tempted. Well, I got it wrong last time.
You want to go to a bar?
Go for the bar in the jumbo jet.
He wants to go to a bar in Stockholm. So let's.
Yeah, no, the Stockholm one is correct. The Underground Bar is one we actually made up. The Stockholm Bar, it does exist. The Jumbo Stay, it's called. The rooms are about 6 metres square, 3 metres floor to ceiling, and you can also walk out on the left wing. It's been turned into a fetching observation desk. So there you go. Right, back to more of you questions that you've been sending in. This one actually was for you, Jim. It was posted on our forum, nakedscientist.com forum. This person says, how do you actually forecast the weather? So how do you actually do what you do and what you earn your money for?
I think the easiest way to describe what happens in the modern meteorologist's office would be that most of us will be looking at the output from the mathematical models of the atmosphere. And using raw data coming in to represent a starting condition, you can then use the equations of the atmosphere, how the air moves, how it exchanges energy, how it exchanges temperature, moisture, and so on. Those parameters can be represented with equations in the model, and it will predict what those numbers look like in a short time step ahead. And if you keep leapfrogging those far enough into the future, you can get an idea of what, say, the temperature field display would look like in 6 hours' time, 12 hours' time. And models now, I used to work as a programmer in the Met Office at Bracknell years ago on the supercomputer. And at the time, this was in the 70s, before we all had computers at home. And the models would split the atmosphere over the globe up into, it's a bit like you can imagine an onion with several different layers. And on that onion, there are lines that cross, like latitude and longitude lines. And each of those grid points represents a data value. And in those days, the computing power was so limited that the data points were 150 kilometres apart. And there were 10 onion skins in this model that represented the real virtual weather. So what happened is that as computers got quicker and more able, we now have models that have data points 4 kilometres apart used regularly to drive your TV graphics, for example, and a lot of aviation meteorology. In some specialist cases, they're 1 kilometre apart. They don't have 10 onion skins, if you like. They have 90. So they're much better able to represent the real physics of the atmosphere. So forecasts have become much better, and you can move them farther ahead in time and still get a good result.
So when you say there is a model, basically people like yourself have written computer programs that know what the atmosphere does, and they put some energy in and how it's going to move, how the air masses are going to move, and how that energy is going to change the behaviour of that patch of the Earth's surface. And so we know from experience, but also from modelling, how it's likely to play out and how that's going to move around, and therefore what it's going to do to weather patterns and systems around the world. Is that what you...
That's
you mean?
essentially it. And the interesting follow-on from that, actually, which is probably far more significant and important, is that when you've tuned your models to be successful in the short term, you know pretty well that the physics is working reasonably well. They're still not powerful enough to represent individual shower clouds accurately, but they can get them in a sort of parameterized way. But nonetheless, the interesting point is that once you know they work, what's to stop you running it not for next week or the week after, but running it for next year, the year after that, and the year after that, and so on? So you run these models for a model world's worth of 30 years' data, and see if the average temperatures that you calculate match the average temperatures that we have in our current climate. So you've calibrated the model to represent what we have now. And then you can play God and do all the things that climate change people are interested in, which is you can chop down the Amazon rainforest, you can irrigate the deserts, you can melt the polar ice caps, and you can run the models again and see how those values change. Now, you won't be able to represent it exactly, but you give the scale of direction of where it will go. And it's the refining of those models that gives people the various answers about what climate change might look like in 100 years' time and so on.
It's certainly true that the quality and the apparent accuracy of weather forecasting does appear to have improved dramatically in recent years. Now, talking of the weather, we've got this question for you, Jane, which Adam has sent in.
Why does the sun bring out freckles?
So what is a freckle, and why does it make Adam go freckly? Or anyone, in fact.
So I'm detecting a little bit of an Irish accent with Adam there. And it may be that if he's from Ireland, has seen a lot of people with freckles, because they are much more common in people with red hair or reddish hair, and particularly from the Celtic races that have moved to the British Isles many, many years ago. So a freckle is a little patch of skin where the melanocytes, that's the cells that make the pigment in the skin, the melanin, they're a little bit more efficient at changing the effects of the ultraviolet light to produce more melanin. So between the freckles, obviously, is much paler skin that will tend to burn more easily. So in those areas of skin, the melanocytes just don't make as much pigment and as efficiently. If you've got very dark skin, then your melanocytes are very, very efficient at making the pigment, and obviously the skin looks darker with or without sun.
Does that mean that if you then retreat from the sun, or when winter comes, same thing pretty much, isn't it? And certainly in high latitudes like where we are, that your skin then regresses to a non-freckled state? Freckles are not permanent.
Well, you can usually see the freckles even if you never go out in the sun or at the end of winter, but they become much more marked once spring and summer comes, because those freckly bits, the darker bits, start making more pigment, and the bits in between don't.
Thank you, Jane. Now, from people who've been out in the sunshine to people who are out under canvas.
My family go camping a lot. What's the best way to remove a tick? Are they dangerous?
Lawrence, what do you think?
There are several different types of ticks. They're all part of the spider family, the arachnids. In the UK, we mostly have hard-bodied ticks. So these are little creatures that tend to live in long grass and in bracken. If you're walking through, in forested areas, if you're walking through there, they can climb onto your skin. They don't fly or they don't leap, as some people think. And then once they're on your skin, they burrow in. They've got little mouth parts that they insert under the skin, and they actually secrete a cement-type substance within their saliva to really root themselves in quite firmly. And then once they're in there, they can feed for certainly hours. Sometimes they can feed for days. So I think the key thing with ticks is actually a lot of the disease transmission that occurs with them comes towards the end of the feed. And so the priority really is getting them off quickly. Again, as with the jellyfish, there's lots of stories and methods that aren't really valid. So smothering them in Vaseline, burning them off with a lighter, all of these sorts of things. I think, they're likely to be hanging around on your skin for ages, or you're likely to give yourself a burn or a worse problem, to be honest. So the key thing is you want to get their tick out intact. So with some really fine tweezers, get right to the base of it and try and pull it out with the mouth parts intact. So a nice straight pulling motion, not too much twisting, because otherwise it'll break. you'll be left with the body of the tick coming out, the mouth parts left in. So close to the skin, fine tweezers, straight pull. You can actually buy devices. You're probably best place to get them is a pet shop or a veterinary surgeons that they're specifically designed to do this. The other thing never to do, don't squeeze the body of the tick, because all you're doing there is squeezing all of the saliva, all of the blood from previous hosts with all of these infections, and it's going to go straight in, and that's the worst thing you want to do.
What sorts of things should people look out for if they find that they have been bitten by a tick? What should they be aware of?
So I guess that also depends whereabouts in the world you are. There are literally hundreds of tick-borne diseases. In the UK, and particularly in East Anglia, where we're based at the minute, the most common one is Lyme's disease. So initially, this doesn't, after infection, there can be a period of several days, sometimes several weeks, and then you can typically develop this rash that looks a bit like a bullseye around the site of the bite. That then generally fades, and actually if it's not treated at that stage, it can go on to cause more disseminated problems. So it can cause joint pains and joint aches. It can really cause neurological problems, so nerves can stop working. You can end up with numbness or weakness in areas. It can even affect the heart. So it is quite a serious condition. The good thing is if you detect it early, you can treat it very effectively with simple oral antibiotics. So I think the thing to do, if you've had a tick bite, we wouldn't need to treat every tick bite, because actually this transmission doesn't occur particularly often. But if you have a tick bite and then you get a rash, you just need to go and see your GP and treat this.
Thank you very much for that, Lawrence. Now, from ticks in the forest and nights under canvas to the seaside. Jim, one for you. Mike wants the answer to this one.
Why does the sea feel warmer in the evening than in the morning?
Now, is that Mike's psychology, or is he correct in his estimations that the sea is warmer in the evening than it is in the morning?
I would say, strictly speaking, there's quite often no difference at all in the sea temperature. Water's very good at spreading energy through great volume. So sea temperatures, when you look at the deep ocean temperatures, or say the North Sea or the English Channel, they might be within 0.5 of a degree for days at a time. So you won't get a diurnal change. I think we should be more talking about what the beach is like, because one of the things about being at the seaside, of course, is that most beaches that are popular are sand. And sand is very good at retaining the energy from the sun during the day in the top few millimetres of sand grains. And sand grains also have big air gaps between them, so that's a good insulator. So it's very hard for energy from sunlight to penetrate deep into sand. So you know from your holidays in any sort of climate, but particularly heat waves like the one we're having in the British Isles this summer, you walk on a sandy beach and it's really hot to your bare feet. And sandy soils are particularly good at gaining heat quickly and losing heat quickly. So let's say, for example, you're going to the seaside at dawn, you've got out of your tent, pull back the door and you think, yes, let's go and have a swim before breakfast. The sandy beach will have cooled overnight, so it'll be at its lowest temperature. You go into the sea and your feet are cold and it feels quite chilly, but let's say the tide is not in yet. But when the tide comes in across it's just coming in, comes in across the cold sand, it's not warmed up. You compare that to the second half of the day when you've had the whole day's sunshine heating the sand and the tide comes in over, it's like moving it in over a hot plate. So the water, the shallow layer of water that you're splashing about in, is immediately being warmed from below. And the sea will feel warmer. And actually it is warmer, but the deep, well-mixed water offshore isn't changing much at all. So I think he's absolutely right with the observation.
I did quite a bit of sailing in my youth on estuarine waters, and you used to find that the water on the outgoing tide at the end of a day was a lot warmer because the tides come in over very, very hot mud flats and absorbed all the energy from the mud, exactly as you're saying, Jim. And then when that water goes back out to sea again at the end of the tide, it's a lot warmer.
It's something that happens particularly in some parts of the country where you have very, very shallow estuaries, like the Wash in East Anglia is one, and that affects temperatures of the land nearby. So there'll be many places around the world where you have deltas and such like, where you've got these shallow seas, and the temperature on the land will be affected greatly by whether the tide is in or out. And that can also affect whether, when you get mist and fog from the sea rolling inshore, that warms warmth that's given over the mudflats will determine whether the fog evaporates before it gets inland or not. And you can have a very different day at the seaside depending on whether the tide's in or out.
Thank you very much, Jim. Lawrence, here's a question for you.
Why do I get motion sickness on a plane or boat?
Motion sickness, what's it all about?
Okay, so this is to do with the way your brain processes information from different senses. So we have our vestibular system. This is little semicircular canals of fluid that are a part of the inner ear, and they're what the body uses to sense movement. So when the head moves around, the fluid within these semicircular canals moves around, and then we can detect that as movement. Now, the brain then matches that up with information that's coming through from the visual sense as well, from the eyes. And we experience motion sickness when the two of them don't marry up together. You know, for example, if you're driving in a car and you're looking out of the windscreen at the front, you've got the visual information coming in, your vestibular system is feeling the direction you're going in, the movements you're making, and you're less likely to feel travel sick under those circumstances. But if you're in a plane, maybe with a bit of turbulence, and you're trying to watch a movie on the screen in front of you, or you're trying to read a book, the visual information that's coming in is that everything is static, there's no movement, but your vestibular system is telling you that things are moving, and the brain doesn't like that.
So let me get this straight. There's a disagreement between what the brain thinks the eyes are telling it and what the ears are telling it, so logically it throws up to solve the problem. Why? That doesn't seem logical at all. It seems nuts.
No, I was trying to work this out myself. I think essentially we didn't evolve as a species to be going in in aeroplanes or to be going in boats at any high speed. There's a vomit centre in the middle of the brain, believe it or not. And when these mismatches occur, the vomit centre gets stimulated and the activity builds up, and it rules. it does rather rule the day. So I'm not sure there's an evolutionary advantage to being really sick. The other interesting thing is
maybe it's a deterrent to not do what you were doing that made you feel like that in the first place. Don't do it again.
Well, no, but the interesting thing is you do it more and more times, your body habituates, so that.
But it gives in, I guess.
It gives in. Your senses adapt to it. So actually, when you've been at sea on a cruise boat for a few days, you get your sea legs and you stop feeling the motion sickness.
Have you ever had that thing actually where you get Erasmus Darwin, who was Charles Darwin's uncle, I think, was he his uncle? First described it and said. He called it mal de débarquement because people who had been on the mail coach, he described it as the stagecoach that drove the length and breadth of the country carrying mail around. When you get off that after a long giddy journey, you would still sense this sense of movement in the absence of any movement. And then people realised it's the same with ships, planes, that kind of thing.
Absolutely, it's because your inner ear and your body's habituated to the fact that you're moving, and then the movement stops, and essentially you have to habituate the other way there. So it's the change in environment. And what makes it more interesting is that actually that because it's a brain thing, there's other areas of the brain that feed into it as well. So people that regularly experience travel sickness, and my brother's a prime example of this. He's been travel sick. I've childhood memories of him throwing up on every roundabout in our holidays. You go on a plane with him now, and he starts vomiting even before you've taxied onto the runway. So it's the psychological element that feeds in as well. No, I try to avoid it, to be honest. At least sit at a good distance apart.
Well, from that wonderful topic, and apologise to anyone who's currently trying to digest any kind of meal, Joe on Facebook is appealing to you, Howard, to help him out and answer the question, what are the best and worst plants to help out bees?
Okay, well, bees feed primarily on pollen, which has lots of proteins and lots of all of the other components that are needed to feed the larvae, and they also feed on nectar. So we heard about the pollen earlier, which causes problems through causing hay fever, but we also have lots of plants that have co-evolved with insects to produce beautiful flowers and attract insects, which then spread the pollen. And so those are the sorts of plants that you'd want to plant in your garden. You'd also want to plant some that are going to flower throughout the season, early spring, through the summer, through to autumn, and just to make sure you've got a continuous supply of pollen and nectar.
So, Howard, those are the good guys, but flipping it round a bit then, are there any things that are particularly bad for pollinators, things that look great but they're nice from far but far from nice?
Well, there are some early plants like ferns and conifers that, again, aren't very good for bees, but there are some plants that actually have their own neurotoxins. And rhododendron, that invasive plant that causes so much trouble in some of our forests and uplands, actually has its own psychoactive neurotoxins called granotoxins. They have their very own novichoks, which are able to poison, well, people who eat honey that has been made by the bees from rhododendrons.
So it doesn't poison the bees?
Some bees are able to tolerate it, although it does affect some bees a little bit.
So it just seems a bit counterintuitive that plants should seek to poison their pollinators.
Well, it's probably an accident. It's probably that the poison spread through all of the plant to stop animals grazing and also accidentally gets incorporated into the nectar.
Thank you very much for that, Howard. Jane, very important questions come in for you. Sarah wants to ask the following.
When should I get a mark on my skin checked out? How do you know if there's a problem?
That's a really important question, particularly this time of the year when people start wearing less clothes and noticing the marks on their body. So I guess we're really worried about the possibility of could a mark be a skin cancer? And they are happening at all ages, but they do get more common as the years go by. But if you've got a mole that looks different to the others, and if it's changed, then you should certainly get somebody to have a look at it. So always better to have somebody who can have a close look at a dark patch on your skin, a mole that you think isn't like the rest or has changed. Don't sit on it or ignore it. Always get it checked out.
And when you say it's changed, how might it have changed?
Moles do change a little bit with life. They sometimes get a bit more sticky out. They sometimes change in colour. But if you've got a flat mole that's grown and it's not grown with you, like a child getting bigger. If it's grown and your other moles haven't grown in its diameter, or it's got one side of it that's growing more than the rest, then that should be a worrying sign.
And someone would, in their first instance, go and see their GP like Lawrence?
Yeah, they'd go and see their GP like Lawrence. If it may not be a mole because there are other marks on the skin that are brown, so the GP could certainly say it's in the worrying category or it's not, and then if there's any uncertainty about it, they'll be sent into hospital for a second look.
And they see someone like you?
Then they'll see someone like me.
Thank you, Jane, for that one. And this is a very important topic, isn't it? Because as we mentioned, the rates of skin cancer have rocketed in the last 10, 20 years. They're more than 100% increase, I think, is the statistic.
Yes,
isn't it?
I remember when I was a young dermatologist, we were all amazed when somebody presented with a melanoma, and now it's a daily occurrence.
Writings on the wall. Now, a lot of people are complaining that when we have a drought, we have a hosepipe ban and they can't water their lawn. And that's probably what prompted Liz to send in this question for you, Howard.
Why does the grass turn yellow when it hasn't been watered?
Sure. Well, it's a question really that of how grasses grow, because you'll all recognise that you can cut grasses regularly, but you wouldn't take your lawnmower to your herbaceous border now, would you? And that's because grasses grow from the base, their leaves expand up, and that's why we can keep cutting off the leaves normally, and they'll regrow again from the base. But they're also adapted to grow in drying conditions, and they also store lots of reserves in their roots. So basically at the same time they'll be packing away reserves into their roots, and so when they get a really dry period they dry up completely. But don't worry, you don't need to water your lawn. Many of the colleges we see in Cambridge aren't watering their lawns because we know when the rains come back the grass will regrow from those reserves.
It does come back incredibly quickly as well, doesn't it? You look at this thing, it looks like a complete desert. It's completely brown, and just a sprinkling of water later, and within literally minutes it's begun to come back to life.
Well, I wouldn't say minutes. There are some plants that are able to come back like that. They're called resurrection plants.
It looks very much greener as soon as you dampen it.
They will regrow very quickly, certainly. Yeah.
Well, there you go. Take reassurance from that. Lawrence, you're going to have to be really quick with this one, but Eric has exercised about jellyfish.
What do I do for a jellyfish sting?
What can he do? Lawrence, help him out.
I'll try and be quick on this one. So there's a lot of myths about jellyfish stings. So the first thing I'd say is that the old kind of myth of urinating on a jellyfish sting is absolutely false. And
really?
We
That's out?
No, it's not. Yeah, urea as a compound may have a beneficial effect, but your urine isn't going to be concentrated enough in urea to have any benefit. So don't urinate on it. The best thing to do, if you've got some vinegar, like we all take that to the beach regularly, but if you could put something acidic like a vinegar on it, that will help to stop any tentacles from releasing further venom. You can't put fresh water on it either because the jellyfish and nematocytes within the tentacles are very sensitive to the osmotic pressure of the fluid around them. So actually putting fresh water on there will stimulate more venom release.
So you have to get someone who's really dehydrated to pee on you.
I think you'd have to be really dehydrated for the peeing, seriously dehydrated. The best thing is to apply something acidic like vinegar, or you can actually buy jellyfish sting sprays that you can put on. Or failing that, Best thing is to wash it with salt water. And then after you've done that, you need to try and remove the tentacles. So either with some tweezers or failing that, get your credit card out, scrape it down the skin, try and remove them off, and then wash in hot water after that. That's the basic advice.
Now, that really is a novel use for a credit card that I haven't had suggested before. Thank you very much, Lawrence. That's it for this week. Thank you to all of our guests. You've been listening to Jim Bacon, Jane Sterling, Howard Griffiths and Lawrence Kemp. The producers were Izzy Clark and Georgia Mills. Do join us next week when we take a flight through time, because we're exploring the 100-year evolution of the fighter aircraft. How did we get from aeroplanes made of fabric and wood to the F-35 Lightning? Join us to find out. The Naked Scientist comes to you from Cambridge University, and it's supported by the EPSRC and Rolls-Royce. I'm Chris Smith, and thank you very much at home for listening. Goodbye.